Okay, here we are. Okay, here's the card that's on your reference sheet. It says any function has an inflection point when that function changes concavity. So they're showing us a graph of f. And you are being asked to identify how many points of inflection. How many points of inflection does this graph of f have, as on the interval shown? So you're simply looking to see how many times f changes concavity. So different teachers do this in different ways. The way I like best is this. If the graph has that shape, or any portion of that shape, then you're looking at a concave up curvature. If the graph has this shape, or any portion of that shape, you're looking at a concave down curvature. So raise your hand, please, and tell me, initially, right here, are we looking at concave up or concave down? Just raise your hand. Is that concave up or concave down? Everybody. Is that one concave up or concave down? Let's go Nixon.
Concave down.
Say it louder.
Wait, sorry. Can you ask that again?
You're good. So what you're looking at is this little portion of the curve a part of that kind of curvature here, or is that portion of the curve up there a part of this curvature here?
It's concave up.
Concave up. How many new? Two more. Okay. So initially concave up. If we keep going, say like here, just say it together as a class when I prompt you. Would you say concave up or concave down? Say it. Concave up still. We're looking at about this portion of the curve right here now. So this little part here in red, that's right here. So still concave up. As we get over here, it's a little hard to tell there. So don't worry about it. Just move on and kind of go to a place where it's easier to see. So raise your hand. What type of curvature are we seeing here? Hands up. What type of curvature are we seeing there? Here we go. Let's go, Sarah.
Concave down.
Sarah votes down. How many voted down? Two more. So we've switched to this portion of the curve right here. Concave down. We keep going. See about right there. Say it together as a class. Concave up or concave down? Say it. That was kind of a mix, I think. We're actually right here about. We're still on the concave down portion of the curve. Then it gets a little hard to tell again. Right here is a little bit vague. Now it's more obvious. Raise your hand, please. Concave up or concave down? Raise your hand. There we go. Let's go, Trevor.
Concave up.
Concave up. Who agrees? Two more. Okay. So concave up again. So in summary, concave up, then kind of uncertain for a while. Then we switch to concave down, then a little uncertain. Then we switch back to concave up. All the way to about there. Then we're uncertain again for a bit. And we switch finally back to concave down. Inflection points are the switch points. So it's how many times the curve switched concavity. So 1, 2, 3. Please, Mike.
Like if there was like an x to the second graph, right, it wouldn't have any changes in concavity because it would just be one single thing. So even though like obviously the slope changes from positive to negative at one point, doesn't necessarily mean that there's an inflection point at all.
That is correct. So this 2 for Michael. The slope changing from positive to negative is not related to concavity. Concavity means the curvature changes. It also means that the slope changes from increase to decrease. Like right here, this slope of f is negative, then this slope is more negative, less negative. This slope is even less negative. This slope on f is 0. The next slope on f is positive. And then the slope of f is getting more positive. So the slopes of this f graph are increasing. If the slopes of f are increasing, the slopes of f are increasing, that means f must have been concave up. Yes. That's what concave up means. The slopes of f are increasing. So, different than the y values of f increasing or decreasing. So, or also different than the slopes being positive or negative. So, that makes sense.
Yeah.
Go ahead.
So you could like have a graph. So you see that like left portion of this, where it just repeats that pattern of like almost like a staircase, like a curvy staircase, and it would have like lots of points of inflection. But it would never necessarily have a point of relative max.
That's perfect. So Michael's imagining some graph that does this. He's noticing that the slope is always negative. Yep, the whole way the slope is negative. Because f, the whole way, is decreasing. Therefore, the slopes of f have to always be negative. But the concavity does change. Because the slope of f here is negative, but then getting less negative, and then less negative. So that means the slope of f in this region is increasing. And sure enough, you can see that the slope, the curvature there is concave up. Then the curvature changes to concave down in this region because the slopes of f are now decreasing. This slope is negative. This slope of f is more negative. This slope of f is even more negative. So when the slopes of f are decreasing, you have a concave down curvature. Switches back over and over again. This graph in green would have 1, 2, 3, the way I've drawn it, 4 points of inflection. Is that what you meant? 2 more. There we go. It's solid. Okay, so we're done with 5. Correct answer was 3 for 5, and we kind of answered a couple of other things. Let's stop the video.